This video will show how to build a sun tracking platform designed to keep a ring solar cell aligned with the apparent motion of the sun as it moves from east to west. The tracker platform requires neither batteries nor electrical components other than solar cells and a DC motor. Its purpose is to provide single-axis horizontal rotation for an attached ring solar cell. The ring camera solar cell is mounted on the tracker platform and will perform the battery charging function for the ring spotlight camera. The vertical axis is manually controlled by a hinge on the ring solar cell. The solar cells can be represented as batteries as shown in the diagram. Each cell is 6 volts at 1 watt. The watt is a unit of power, so to get the current capacity of each cell, use the power formula, power equals volts times current. So current equals power divided by voltage, or 1 divided by 6, which equals 167 milliamps per cell. Since this is a series parallel configuration, each side provides 18 volts at 334 milliamps. On the diagram, the left panel B1 through B6 deliver 18 volts at 334 milliamps with a positive voltage on top. The right panel, B7 through B12 deliver 18 volts at 334 milliamps with a negative voltage on top. If the left panel is dark, the right panel will drive the motor in the clockwise direction. If the right panel is dark, the left panel will drive the motor in the counterclockwise direction. The motor activity will continue until the voltage across the motor terminals is 0 volts, which occurs when the front of the tracker is pointing directly at the sun. The tracker should be oriented with the front pointing in the southerly direction. This way, when the sun is in the east, the motor will rotate towards the left. When the sun is setting in the west, the motor will rotate towards the right. If you get the opposite result, switch the wires at the motor terminals. To test an individual solar cell, use a multimeter and hook it up as shown. Set the meter to DC volts and position the cell in front of a strong light source. The reading should be at least 6 volts. The solar cells are stacked as shown. 6 cells face the east and 6 cells face the west. The 6 cells in each silo are glued to wood strips that are used to form the backbone. The white plastic support structures are printed on a 3D printer. Here you see the left and right sun-facing cells, angled at 116 degrees. To test the entire structure, we use 4 batteries to power the motor. This is because a light source other than the sun will not provide the necessary frequency spectrum to provide enough current to drive the motor, even though a strong lamp will generate the 18 volts. We start with the lamp illuminating the left panel, emulating the morning sun. We see a positive 18 volts on the multimeter. As the tracker rotates to the left under the power of the batteries, it emulates the afternoon sun and the positive voltage decreases, passes through 0 volts and increases to negative 18 volts. The printed components are shown here. They are available for download as STL files from cgtrader.com. It shows the driving and driven pulleys, the support structures and the clips for the ring solar cell. Here you see the driving and driven pulleys. The driving pulley is mounted to the motor by a notched center hole to grab the motor shaft. The driven pulley is glued to a metal bearing-filled turntable.